Let's take a look at this problem. We got f of x is equal to 5 plus 1 over x, and g of x is equal to 2 over x. Okay, we want to find f plus g. So again, you always do the same thing. You put parentheses around each function, and you put whatever operation in between them. So parentheses around the function plus, and then parentheses around the function. Now this one, this becomes, these parentheses aren't doing anything, and these have the same denominator, so you add the numbers on top. 1 plus 2 is 3. So we got 5 plus 3 over x. Now this is a mixed number form, so we're going to take the number to the side, multiply times our denominator, and then we'll add our numerator. And then your denominator stays as is. So again, take the number out to the side, multiply times the denominator, add the numerator, and then your denominator stayed as is. Which gives us 5x plus 3 over x. Now for our domain, we got a fraction, and remember our steps for finding the domain when you got a fraction, you just set your denominator equal to 0 and solve it. And, well, this is already solved. And then you put a slash through the equals. X cannot equal 0. Because if I put 0 in for x, it'll cause the denominator to equal 0. And interval notation wise, this will go from negative infinity to 0, union 0 to positive infinity. Now f minus g. Same thing, we'll put parentheses around each function and put a minus in between them. Well, we got 5, and then 1 minus 2 gives us negative 1 over x. This is again a mixed number form. So we're going to take the number to the side, multiply times our denominator, so 5 times x, and then we'll add the number up on top, and that negative has to go at the top. And then our denominator stays as is. So again, the number out in front times our denominator, add our numerator, and denominator stayed as is. Which gives us 5x minus 1 over x. Same idea as this one. Our domain would be the same explanation. Okay, f times g. So I'm going to take again, put parentheses around each function. Now I'll take the one function times the other function. And this will be the distributive property. So we'll take the 2 over x and multiply times the 5 and multiply times the 1 over x. 2 over x times 5 gives us 10 over x, plus 1 over x times 2 over x. 1 times 2 is 2, and x times x is x squared. Now we want to get a common denominator, which would be x squared. If you have x and x to the second power, it's 1 with the larger exponent. Now this one already had an x squared, so I'll leave it alone. On my first fraction, I multiply the bottom part by x, so I have to multiply the top part by x. So that gives us 10x plus 2 over x squared. And again, we have a fraction with a variable in denominator. So we set our denominator equal to 0 and go through, and we get the same domain as the previous 3 parts, or 2 parts. Okay. Let me scroll down. And then we got f divided by g. And what are we talking about? 5 plus 1 over x divided by 2 over x. Now this is a complex fraction. Complex fraction is where you got a fraction inside of a fraction. Easiest way to get rid of a complex fraction, the way that works 100% of the time, is to multiply everything by the LCM of all your inner denominators. Now when I say inner denominators, I'm talking about that x, and I'm talking about that x. Where LCM of x and x would be x. So I'm going to multiply the 5 by the x. I'll multiply the 1 over x by the x. And I'll multiply the 2 over x by the x. Now x times 5 is 5x, plus these x's cancel, gives us 1. And these x's cancel and gives us 2. Now this is one down here. It says what is the domain of it? And you answered from negative infinity to 0, 0 to 2, 2 to positive infinity, and they're just saying that x cannot equal to 0. Now, even though our x disappeared from the denominator, we can't set a domain that violates our original form. So that's why it's the same as the previous ones. Our domain is from negative infinity to 0, union 0 to positive infinity. Now you came up with 2, but the only reason we'd have to worry about that is if that was a variable there. That's just a number 2. And 2 is fine. We're just specifically looking when you have a variable in your denominator.